Thank you for your joining to the video lecture. The subject of our lecture is computer-aided design, monitoring and control of measured water allocation in open canal systems in spatiotemporal dimension. The aim of this investigation is to devise a computer program that provides measured water allocation in open canal systems and to apply it on an existing network to evaluate the results. The main window and the components that appears on the screen when the program is opened. The first module is the hydraulic database module, and we see here a canal segment, trapezoidal canal segment. At the beginning, inflow of the segment, and the other side, outflow from the segment, upstream and downstream, and the other hydraulic parameters of the canal. This module contains all hydraulic data obtained from measurements made on the canal system. Another module is the real-time calculation and data recording module. This component provides the following items: real-time registration of flow data in canals, processing their values in a program, save the results to files, and real-time flow analysis. Here we can see the sample interface of this module. The other module is the registry correction module. The task of this module is to go back to one or more time points in the past, correct the erroneous data there, and return to the real-time period by defining the correct record at the same time point while time flows continues in reality. The other module is temporal and spatial flow report module. This module is used to examine the details of the flow of data occurring in any time period. Analysis of simultaneous flow of data from different measurement points is important for a balanced water distribution at the network level. In this way, it is decided whether to interfere with the flows occurring in the upstream and downstream parts. The other module is the main recording module. All data records at measurement points are presented to the decision maker with time-dependent consecutive record numbers. Thus, the user can examine the data received on the same day by dividing it into sections with year, month, day, hour, minute, and second precision. Seasonal flow reports can be prepared without the need for any additional processing. This output can also be considered as a seasonal record. The other module is the user interactive irrigation programming. This module contains the following items: the irrigation period in which the planning will be made, The other one, name and type of each canal. Water carrying capacity, irrigated plant pattern, length of irrigation time allocated to each canal during the system rotation period, efficiency values, irrigation water requirements of crops in the plant period, the maximum amount of water that can be taken during the irrigation period allocated to the canal, water constraint levels in the area served by each canal. Also, registry correction module, here we can see. In this module, interactive calculation series containing a large number of parameters are executed simultaneously. And the other module is alternative irrigation programming module. Parameter options of creating alternative irrigation programs. This module used for this purpose. Canal water carrying capacity, irrigation time allocated to the canal, plant pattern, irrigated area size, and irrigation water requirements. The value of all parameters will change. This module is used for creating alternative solutions by changing all the components of the system. Options for changing record definition parameters are also canal type, irrigation period, and canal segment number. Also, we have alternative planning detail form here. In this application, alternative irrigation programs can be created depending on the change in irrigation times allocated to the canals. The aim here is to decide the most appropriate irrigation period for each allocation zone by analyzing the water constraint levels occurring in different canals. Also, the water budget analysis module by volume is another module in this application. The volume of water, by running this module, the volume of water taken from a particular segment in any given time period is determined. The amount of water given to the network and its distribution are monitored temporally and spatially. Seasonal water budget for the system is created by this module. Detailed report files of the irrigated area are also prepared. Processing of hydraulic parameters obtained by the measurements in open canals in computer medium is carried out by using these software. Also, hydraulic calculations in trapezoidal canals are carried out by using these interface forms. So, when this model is applied on real agricultural production conditions, we can see from here. The investigation was carried out on the area served by Sarıkız Irrigation Association, located within the Gediz Basin, Ahmetli Regulator, Right Bank irrigation system in Turkey. Here in the map, we can see the location of the research area. Within the scope of this investigation, findings from the Gümülceli region will be presented and analyzed. Procedures were carried out similarly in other regions of the same network. Here we can see some segments of the open canal irrigation network in the research area. There are 5 main reasons for examining the data of Gümülceli in this study. The first one is Gümülceli region has a very important location in terms of water distribution. Water inflow to Sarıkız and Gediz irrigation associations is made from this region. Also, in the second place, Gümülceli region is in constant interaction with Ahmetli and Turgutlu in the upstream and Sarıkız and Gediz irrigation associations in the downstream. This situation is of great importance in terms of irrigation planning. Sarıkız and Gediz irrigation associations jointly use the tertiaries receiving water from A9, A11, A30 and A40 secondaries on a rotation basis. Therefore, in this region, the network is used interactively on a rotation basis, both at the main canal and secondary canal levels. Ahmetli, Turgutlu, Sarıkız, and Gediz irrigation associations receive water from the Ahmetli right main canal, respectively. The sizes served by this area are shown in the screen. As can be seen, Sarıkız Irrigation Association has the largest area in the region, while the water carrying capacity of the network decreases along the main canal road. The size of the irrigated area increases as you move downstream. This is very important in terms of irrigation time and irrigation programming. Here we can see the model flow chart. Here start the other one defining the hydraulic measurement data of the canals in the program, and next entering the flow readings made at certain time intervals from electronic limnographs or scales into the program in the real time. The other one, real-time processing of the flow data canals in the program. And here the results are obtained, saving the results to the relevant database files in the program. And the next one is processing the detailed spatiotemporal report files to the decision maker, and the program is completed. Here we can see daily average discharge occurring in the Gümülceli region, discharge variation curves, and average values in 5-day periods. The flow data in canals are obtained in 2 hours intervals during the investigation. Here we can see the differences of the flow measurements. Discharge values also occurring in the research area for different dates and times. The changing in flows can be seen here from the average values of different dates. Total amount of irrigation water requirement and amount of water actually delivered to the canal in Sarıkız and Gediz irrigation associations can be seen here. In the vertical direction, amount of water as cubic meter, and the horizontal direction, months, irrigation periods. And the blue bars shows the total irrigation water requirement as cubic meter, and the red bars show the amount of water given to the canals in reality. Yes, another activity that should be carried out within the framework of the Agricultural Drought Management Action Plan is creating the most appropriate operating plans at the network level and their application. Thank you for your joining to the lecture.